Good afternoon and welcome back. I hope you had a nice time upstairs. Is everybody back? I hope so. Okay. So the objective of the last session was to do a review of measures, what kind of properties, different or the measures we want to satisfy when we can compare two distributions unambiguously, to resolve the arbitrariness in the choice of poverty line or the choice of poverty measures. Now what I will do in this session is move to the multidimensional space, and as you will see, some of the properties that or the techniques that we used in the single dimensional case are extendable to the multidimensional case. At the same time, there will be certain issues that are very much specific to the multidimensional case. So although the title is probably doesn't justify the lecture completely, it's properties of multidimensional poverty measures, rather it's a framework for multidimensional poverty measurement along with properties. Okay, so let's go through. So again, the source for the lecture is the book that has been shared with you. It's chapter 2.2, 2.3 and 2.5 mostly. Also, the motivating paper would be Bugin and Chakrabarty's 2003 paper, and also James and Sabina's paper, the version 2007, which is more detailed, and also the published version 2011 Journal of Public Economics. And also there are other lists reading from the reading list. So again, for the preliminaries, again we start with reference population. It's very much similar to the single dimensional case. We have a unit of measurement, which we refer as persons, which could be households or which could be for child poverty, children, and so on. As you can see, population size can vary. Then there are variables or dimensions that we refer as space for poverty. Here it is not actually income sources or commodities. That's sort of a mistake here. Sorry about that. This is not exactly the space. The space could be something different. Okay. What is it? So for achievement is just the same. We denote by Xij the achievement of person I in dimension J. The achievement matrix can be similarly defined, and the achievement vector of a person in this case, this is the right one. So it's different dimensions, could be standard of living, could be knowledge, which can be measured by education, quality of health, measured by different indicators. So the achievements here earlier in the income space or commodity expenditure space had different income sources or different consumption of commodities. But in this case, the achievement vector contains standard of living, indicators of standard of living, knowledge, or quality of health. So that's the different departure from the single dimensional cases. Look, this framework is similar. It's same the achievement matrix, but here achievements are achievements on different dimensions that may not be able to be combined meaningfully. And this is how a typical achievement matrix may look like with 4 dimensions. Income, say a typical dimension if you want to include in a multidimensional poverty analysis as 1 dimension. Years of education, suppose sanitation facility, access to electricity. There could be a health variable, there could be other variables as well. This is just an example, and by no way assume those are the dimensions that should be there always. No, this is just an example where we have 4 indicators, just for the sake of the example. And you have the achievements of person 1 in income is 700 with some unit of measurement. Years of education of the person 1 is 14. I have access to improve sanitation? Yes. Have access to electricity? Yes. Okay. Similarly, if you look at the second person, The income is 300. Years of education, say 13 years of education. He has access to improved sanitation facility but no electricity, and so on. This is kind of the data in the multidimensional world that we generally see when we are conducting analysis. So the matrix X summarizes the joint distribution of D dimensions across n individuals. Why we call it joint distribution? When we look at, say, distribution of income only, that means if we just look at the first column where you have 4 different values, that is called the marginal distribution of income. When we just focus on the education, it is called the marginal distribution of education. Similarly, marginal distribution of access to electricity. And when we look them together for each individual, so for each individual we look at them at the same time, this is called joint distribution, looking them jointly rather than looking them separately. So these marginal distributions can be combined to get a joint distribution, which is represented by the matrix. So the row vector, we denote it by this particular notation, x, I and dot. It means the D elements in this vector summarizes the achievement of person I in all D dimensions. And with this particular notation, x dot j, we denote the n elements of dimension j. So this distribution is the marginal distribution of dimension j. So that means if we have D dimensions, that means we have D different marginal distribution of income, distribution of education, distribution of health, access to electricity and so on. And these are the vectors of individual achievements. So person I's achievement in income, education, health and so on. Very similar to the single dimensional measurement. Of course, you have to select the space first. Space means the set of variables and dimensions. And then it has 2 additional steps, which is identification and aggregation. The first step is identification. So what we do first is, who is multidimensionally poor? That's the question that we are going to answer here. Okay? So an identification function, which is denoted by rho, decides who should be multidimensionally poor or who should be not. If a person is identified as multidimensionally poor, then this value takes a value of 1, a function takes a value of 1, and the function takes a value of 0 if non-poor. So you have the data, and based on the achievement vector of each person, you need to identify if this person is poor or if this person is not poor. And that particular identification function is denoted by the symbol rho. So if a person is identified as poor, you assign a value of rho equal to 1. If the person is not poor, you assign a value of rho equal to 0. That's it. In multidimensional context, unlike in single dimensional context, what did we do? We computed the overall achievements, right? A poverty line was selected, and those who had achievement below the poverty line were identified as poor or deprived. This is what we did in the single dimensional context, right? In the multidimensional context, there are 2 different types. Okay, we refer them as one we call censored achievement approach, where we censor. Remember censoring? Did you understand censoring? So here what we do, we censor the achievements of the non-poor. This is called censored achievement approach. And the other one is aggregate achievement approach, where we do not necessarily censor each deprivation. So I will explain in detail. So let's first talk about censored achievement approach. It is done in 2 stages. First stage, determine whether individuals are deprived in each dimension. So you take income and then the income poverty line. Identify whoever is deprived or not. Okay, you can construct a censored vector of income. Look at education and look at the education deprivation cutoff. You can compute a censored deprivation, censored distribution of education, censored distribution of health and so on. So the main idea here is that you do not care at the dimensions where there is no deprivations, particularly for the persons. And then in the second stage, identify if someone is poor based on an identification function criterion. Examples: union criterion. Union criterion identifies a person as poor if deprived in at least one dimension. This is a very common approach that is taken in multidimensional analysis that we will discuss, and we'll see what are the main problems of this approach. The idea is that suppose you have 4 different dimensions and you identify if somebody is deprived. Deprivation and poor, they are not the same thing in the multidimensional context. In the single dimensional context, they are equivalent. But in the multidimensional context, a person may be deprived in particular indicator or dimension, but whether the person is identified as poor or not depends on the criterion used. Now if you look at the union criterion, in union criterion a person can be identified as poor if the person is deprived even in at least one dimension. In a sense, then in union approach, in the context of union criterion, deprivation implies poverty. If you are deprived even in one dimension, you are identified as poor. The other extreme is intersection criterion. In this criterion, person is identified as poor if the person, only if the person is deprived in all indicators. So if you have say 4 indicators, 4 dimensions, and a person is identified as poor only if the person is deprived in all dimensions at the same time. So you see how these multidimensional criterion can use the idea of joint distribution during identification. So you are using the information of each person in all dimensions. You are not just identifying poor based on this one dimension. So this is where you are using all dimensions jointly for identification. And similarly, there is the third criterion, intermediate criterion, that Sabina and James developed in their paper. This is an intermediate approach which identifies a person as poor if the person is deprived a certain number or certain fraction of dimensions, say 2 out of 4 dimensions or 3 out of 4 dimensions and so on. And actually these 2 cases can be seen as special cases of this one, of this intermediate criterion. They may include this situation, but if you want a strictly intermediate case, then of course they have to exclude this union or intersection criterion. So let's take an example. So this is the matrix or the data set that we began with, right? So we have income. So these are the marginal distribution of income, marginal distribution of education, marginal distribution of sanitation, marginal distribution of access to electricity. When you see them together, it becomes a joint distribution. Suppose the deprivation cutoff vector is denoted by Z. So earlier in the income approach, we had a poverty line. Okay? Here we have sort of a line, a threshold for each indicator, but here we are identifying deprivations and not poverty. That's why we refer this as deprivation cutoff and not poverty line. And suppose this is our deprivation cutoff vector. Okay, for income, which is 500. That means if you have income of less than 500 unit, we are going to identify you as deprived in income. If you have education below 12 years, you are identified as deprived in education. Similarly, if you have something less than yes, which is no here, the only other option, then you are deprived in sanitation. Similarly, if you are no, you are deprived in access to electricity. That's the idea. Sorry. So what we do here, first replace entries 1 if deprived and 0 if not deprived in this particular example. And then what you can get, this is what you get. See, the deprivations, for example, income deprivations is these 2. Then you have education deprivation, these 2, sanitation deprivation, and deprivation in access to electricity. And this is what you get. So 1 if the person is deprived in a dimension, and 0 if not deprived. Okay? Alternatively, you can construct a censored matrix. Do you remember how we were computing the censored vector in single dimensional context? We were replacing all the incomes in the single dimensional context of the non-poor by the poverty line itself. Here note, we have replaced all the non-deprivations by the deprivation cutoff. So for this one, we have 300 and 400. We replace the non-deprivations by 500, 500. Here the non-deprivations by 12, 12. Non-deprivation remains, you can replace it by 1, but it remains yes here, and there is no change actually. Okay? The next is sort of the aggregate achievement approach. What you can do here, actually I didn't go far, after you compute these particular censored matrix, you can use this censored matrix to identify the poor, which I am not showing you today, which is the surprise for tomorrow. When Sabina's method with James is introduced, then you will see the particular identification, how this information they are used to identify those who are poor. Okay, so but the main idea is that first you identify the deprivations, okay, and then use these deprivation informations to identify the poor. I gave you examples like union, intermediate, but you will see them tomorrow in a better way. The other type of approach to identification is called aggregate achievement approach. What is the main idea here? A person is identified as poor if our aggregate achievement falls short of aggregate poverty line. Sounds similar to something? In the last lecture, in the last session, we have seen this, right? We aggregate all the income sources or commodity bundles and then identify. But then the question is, if you have education, income, sanitation, how you meaningfully aggregate them? People do, there are methods people have proposed, but not sure how they aggregate. So, but that's the question that we will see, why some method can be used in the multidimensional context and what cannot be used. So this is, as long as you can meaningfully aggregate, that's fine, as in the income or other approaches, but here in this example we are not sure. But this approach can be used, are used in general by some folks. So then the idea is you have such as an aggregation function, you aggregate, and then you have an overall threshold below which identified as poor, otherwise not. An example is the consumer expenditure approach. I do not find any better example in the multidimensional context. Okay? So the note is that no deprivation matrix was created in this situation. So the thing is that you allow, what happens here is that in aggregate, if you look at consumption expenditure approach, suppose you have information on protein deficiency, carbohydrate deficiency, fat deficiency, or micronutrients deficiency. And suppose somebody is consuming a huge amount of protein but is deprived in fat, carbohydrate and micronutrients. But if this person is consuming enough protein, it is possible that his overall achievement is above the poverty line, so identified as non-poor. So it does not matter. But if you had taken the deprivation, censored achievement approach, you would have said, you know what, this person is consuming a lot of protein, it is more than the threshold, so let's not identify, let's not take into account that extra bit, so censor it over there and then look at the other deprivations. Probably that person would have identified as poor. Okay, so same thing, if you try to do that in a multidimensional context, you are saying he has enough education, so what if he does not have any income or poor in health or no access to basic services? Let's just allow this kind of substitution. That aggregate achievement approach will allow that. But if you are looking at censored achievement approach, it will say, you know what, if somebody is deprived in other indicators, they should be counted properly. And even if the person is not deprived has large achievement in something, you just should not assume that they can be substituted. They can substitute all those deprivations. That's the main difference, motivating difference between these two. Now the second step is aggregation. Of course, jumping around. How poor is the society? Same, is the concept is the same as the single dimensional case. So you obtain, so based on the identification criterion, this step constructs an index which is based on the achievement matrix and the set of deprivation cutoff, okay, and so you construct a poverty measure. That's the idea. Okay, again, I visit some of the properties. So it's a recapitulation process. So if you have not understood the properties well or why we require them, please ask me. Okay, but let's go through again with them. So some of these properties, so let me show you. So we classify, as in the single dimensional context, the properties into 4 major categories. Invariance properties. And why they're important? They're important because you need to understand how poverty measures behave due to different data transformations. Invariance property says some sort of data transformations, some sort of changes should leave poverty unchanged. Dominance property says that poverty should change in a particular direction due to this kind of transformations. Third, there are subgroup properties which link the subgroup poverty to the overall poverty. And some technical properties are there. And some of these properties are just natural extensions from the unidimensional properties. So they are almost same. The concept is almost same. But there are some properties that are very specific to the multidimensional context. Because in single dimensional you did not have, for example, joint distribution. In multidimensional context you do. So what is the important implications? How should poverty change because of these different issues in multidimensional context? So of course the first one is symmetry. Could someone intuitively tell me what symmetry means? Loud please. All?
Both sides are equal.
Sides?
Sides.
Say it again please. All sizes are equal. What do you mean?
He said all sides are equal.
Sides are equal. What does it mean? Explain please.
It's the same. Both directions.
So if you have 2 different vectors which has same
Properties.
okay, same incomes and so on, if you just shuffle them around, it should not change basically, right? Anything else you'd like to add?
Yeah, just was gonna say it doesn't matter who's poor.
Right, as long as you have that income, it doesn't matter you or me, as long as we have that income, we should be identified as poor or not. So the symmetry. And technically it's multiplication by a permutation of income. So if you just permute the incomes, you shuffle around the incomes, as long as they are same, your poverty level should be same. It should not change.
But in case of multidimensional, when you're talking about a matrix and you want to shuffle the thing, how are you supposed to shuffle it? I don't think it's possible.
Why not? Shuffling person. I'm just taking.
Now, you give an example of income, that's just a single vector.
Yeah.
But then when you're talking about this, it's a matrix. So they are like, the entire rows are vectors, right? So like.
So what I'm doing here, if you look at it, so I'm just shuffling these 2 rows. So we have 3 persons here, right? 1, 2, 3, and we have 3 dimensions. So what we are doing, we are shuffling the achievements of these 2 persons. So now person 1 has this instead of person 2. Here person 1 has this, and we are just shuffling this. You see? Sorry? You have to take the whole achievement vector. Okay, so as long as you are shuffling the achievements across people, then it should not matter. That's the idea. Okay? Clear? Replication. What was the idea behind replication? Okay,
In this matrix, if there are more number of people but with the same values,
right,
the same row vectors.
right. So it's about cloning. So if you just clone the society, right, if you just increase the number of people but with the same achievement vectors, okay, it is as if each here, what you are doing here for each person, you are just replicating this person's income. As I was discussing earlier, if somebody is of the view that it does not matter the number of population, as long as you have larger number of poor, then one society should be more poor. If you are of that point of view, definitely you will consider probably this society, because this society is likely to have larger number of poor, right, because poor are also replicated. So if you are of that particular view, you would say, no, I don't believe in this property. I would always say, whenever replication takes place, you have higher poverty in here. But if you are not of that view, if you want to bring the idea of population as well, okay, you might say that cloning of population, no, poverty should not change. Because if it happens, then we are always saying larger societies are more poor than smaller societies, which is also difficult to justify. Okay, this property can be defended from that particular side. Scale invariance. What was scale invariance in income poverty approach? By the same factor. So if you equivalently change units, right? If you just change the unit of measurement, should poverty change? The idea is no, poverty should not change. Why should changing unit of measurement should change? Let's take an example. So suppose we have right. So we have this particular vector, this is the poverty line, and suppose we just use this particular type of scale. And so what we do, we retain this row, multiply this row by say twice, and then multiply this particular row say by 3. Suppose we have changed the unit of measurement in such a way. The idea is that then poverty should not be different. Suppose you have 3 dimensions: income, education, and say health. So for income dimension, suppose it was in dollar, I change it to pound. Education, it was years of education, I change it to months of education. And then BMI, instead of 22 kg per meter square, I use something an FPS process. It's just the numbers change. Should that change poverty? Probably no. Okay, there's the same idea here. But again, it could be controversial, as some people think that addition of incomes should be more important than the rest. But otherwise, if you look at from the unit of measurement point of view, this particular property makes sense. Focus. What was the idea of focus axiom or focus property? Our focus should remain on the poor. If we have identified, or here we will see that we have 2 different types of focus properties, but at least in the income approach, the main idea was, if you are doing poverty analysis and if you have a poverty line, then why should you bother about change in incomes of those who are non-poor? Do you agree with that view? This makes sense, right? So that's about focus axiom. Let's see what kind of focus axioms we have in the multidimensional context. Type 1 is focus on those identified as multidimensionally poor. We are not interested in those who are not multidimensionally poor. Fine. But it is even possible, please tell me if I'm wrong, is it possible that a multidimensionally poor may not be deprived in all dimensions? Possible, right? So what about those? So should we allow, if a multidimensionally poor is not deprived in a particular dimension, and in that non-deprived dimension he has improvement, should that affect poverty? So repeat my question.
No.
So you have multidimensionally poor who is not deprived in a particular dimension, and he has improvement in that dimension. Should that affect poverty? Does this? Well, coming to that. Yeah, you are going ahead. Yeah, coming that. I'll come to that. But here, does this focus property prevent that kind of situation? This only says that focus on those identified as multidimensionally poor. Okay? So that means if the non-poor person's achievement changes, there should not be any change.
It depends on also the criteria you establish. Whether if you are defined by one indicator, you are multidimensionally poor, or whether 2 out of 3 or 2 out of 4.
I mean, any of them, even if you have any of them, this is only saying that if there is change in deprivations of the multidimensional non-poor, there is not going to be any change. It is not saying what happens if a multidimensionally poor person's non-deprived dimension changes. That's a second type of, that's why a second type of focus, come on. That's a second type of focus axiom is focus property is required. It says focus on dimensions where multidimensionally poor people are deprived. That means if there is any change in the non-deprived dimensions of a multidimensionally poor, then there should not be any change in poverty. So you see how these two properties are different. So in single dimensional context, you just had to focus on the poor, and if there is any change in non-poor person's income, there is no change in poverty. Because in the single dimensional context, poor and deprived, they were the same term, which is not the case in the multidimensional context. Deprivation does not imply poverty, and poor are not necessarily deprived in all dimensions. So we have two different kind of properties here, focus properties. One focuses on the multidimensionally poor, and the other says not only multidimensionally poor, focus on the deprived dimension of the multidimensionally poor. Okay? So if a poverty measure does not satisfy the deprivation focus axiom, then it is allowing substitution, the example that I gave, that if somebody is not deprived in education but deprived in others, it is allowing substitution of that from that non-deprived dimension to the deprived dimensions. But deprivation focus prevents that. If somebody is deprived in 3 other dimensions but not in education, you just cannot assume, given that that person is not deprived, he should substitute his education. It's not possible in practice, always. Okay? Yes, please.
There is some strong assumption.
Let me give you the mic. Where is the mic? Gisela. Gisela. Here. Thank you.
Although you have, by putting this type 2, you avoided that kind of substitution, but there is a strong assumption that is going on behind that all dimensions that we have chosen, they are independent dimensions to begin with. If they were not independent, then de facto there is a substitution somewhere.
Independent.
In the sense that each poverty in each dimension constitutes poverty in itself. There cannot be any aggregation possible. How to put it? That if I'm looking at 2 dimensions like sweet and meat, let's say, and the 3rd dimension is your health. So somebody is already diabetic. How will you put sweets? There is a cutoff level, but so there is something which is linking, which we are, when we are dealing with this kind of matrices, what we are doing, we are like in matrix algebra, we assume that all these rows and columns are independent. All row matrix operations that we are doing can be done because of the independence. And unless we are not assuming that, it will become hard. So this is my
Very good question and very good point. Look, we are preventing substitution from the poverty line to up. We are not preventing substitution as long as your achievements are below poverty line. So there we are. So what I am doing here, look, what is the policy implication? if you have such things, substitution, and if you do not control for it, the problem is that even when you know empirically, say, let me give you that example again from the Indian context. In the Indian context, the government used a particular strategy to identify below the poverty line. And the strategy used 13 different questions, and each question has categories of 0, 1, 2, 3, 4. Say one category was land ownership. If you have no land, if you have this land of less than 0.5 acre, 0.5 to 1, 0.1 to 3, 3 and or 5 or more or whatever. The idea was you will get 0, 1, 2, 3, 4. These 4 different categories, 4 different values. So 13 questions, your values lies between 0 and 52. Now there are people who are deprived, severely deprived in certain dimensions. Okay? And some people, poor people, they had barren land. They had land, some land, they had barren land. Now it was actually possible to give them little more land so that they jump up from category 3 to 4. Maybe it's a barren land, but as long as you satisfy this category and pull them out with a total score out of poverty. So if you allow that kind of substitution always, what it does is that even when you can see properly, no, improvement in this dimension, probably they should not just take them out of poverty. It gives the policymaker an incentive, again, to deliberately ignore the deprived dimensions and only help them where they think it is feasible, just increase, it's easy to increase. Okay? So that kind of, now when you are talking about independence, independence has to occur across the entire dimension, entire distribution, then you call them independent. But you are allowing substitution up to a certain level. Okay? When you are doing aggregation, you are allowing a certain level. What you are preventing here, if somebody is eating too much protein, okay, that should not just cause them to say, okay, even if this person cannot purchase fat or what for some reason it cannot consume, we should overlook. That probably should not happen. That's the main idea. I mean, it could be, you could controversy, you could debate it, but that is the main idea behind this kind of focus axiom. Okay, that's the motivation.
Can I
Yes,
one
please.
question there?
Of course.
So far in the discussion, are we treating all the dimensions equally weighted so far? Or
I have not spoken anything about weights here.
not? Okay. So it's,
They're general assumptions.
it's
Weight.
general
Yeah,
assumptions. So among the deprived dimensions then, from policy purpose, okay, I identified these are the deprived dimensions. Out of 8, suppose that's 4. So how do you treat them? Hopefully you're going to explain it, or is it
Tomorrow.
tomorrow? Tomorrow.
It will come gradually. It will come gradually. It will come tomorrow. It will. That is the main idea. That is the discussion that will take place when we will have, first of all, the methodology that Sabina will introduce. Then we will have normative choices. In normative choices, we will discuss about different cutoffs that is used, how to choose deprivation cutoffs, poverty cutoffs, how to choose indicators, dimensions, and so on. But we will talk about it, but not in this lecture. It will come.
Thank you.
Any other questions? Yes, please. Let's use the mic so that everybody can.
In relation to his question about
Yes.
the independence of these each dimensions, I think he's asking about whether these dimensions are exogenous of each other. So it would not affect, for example, education. Might be due to health reasons. Then you have this dimension about access to health services. Then that would affect the education.
Sure. Look, whether education affects health, health affects education, it's a big question. And I am not saying they're not important. What we are trying here to see, if somebody is deprived in education and health, and somebody is only deprived in education or only deprived in health, the person who is deprived in both, his poverty or deprivation is much more severe than the other two. That is what we are just saying here. We are not saying here that, of course, some dimensions are more correlated. Water, sanitation, you might say, they are more correlated. I mean, of course, you can empirically test the correlation between them, and they have been done by Mariam and Sabine, and we will discuss all these issues. And good that these questions are coming up. Yes, there are. And another thing is that we do not exactly empirically know which one affects which one and at what level. So that also requires several assumptions which is difficult to justify. What we are doing here, of course, there could be relationship, and we are not saying they're independent at this moment. That's an assumption. We are allowing substitution up to certain level, but we are saying that you keep on only increasing one dimension and assume substitutability, and the person comes out of poverty. Just like cash transfer, give them cash transfer, everything will be solved. I think that's there's a difficult assumption underneath, right? Because you keep on giving as much income, everything will be solved automatically. Even the public health care will be solved automatically. Public education system will be solved automatically. Probably that's not the case. So that's why it is quite important to identify the deprivations than just assuming substitutability for at any level. That's the motivation. Any other questions before we move on? Okay. So here is the definition. So if y is obtained from x, so a joint distribution is obtained from another joint distribution by an increment to a non-poor person's achievement, then deprivation cutoff factor remains unchanged. There is no change in poverty. So consider the situation where you have a non-poor person, a person who is non-poor, but maybe deprived in a dimension. Okay, it is possible. But even then, if that person's deprived dimensions increase, because the person is not poor, there should not be any change. So even if a non-poor person's deprived dimension, faces improvement, there should not be any change in poverty, because we have already identified the person as not poor. That's the main idea. Again, so annoying.
Sorry.
Yeah.
Reference to your last statement, I think the emphasis here is deprivation rather than poverty.
Sorry?
Deprivation is the key thing. The emphasis here is deprivation, people deprived of something, rather than poverty.
No, I mean, you are identifying people as poor or not first,
Based on deprivation.
based on their deprivation or however. Suppose you take the aggregate achievement approach, where you aggregate everybody's.
Okay,
That's allowable. That's allowed here. What you are doing, somehow you have identified somebody as poor.
Yeah.
Suppose somehow, it could be any approach.
Yeah.
Suppose you have identified somebody as poor,
Yeah.
and you know who the non-poor are.
Yeah.
Any change in the non-poor's achievements will not affect poverty. It may be their deprived dimensions, maybe their non-poor. That's what it's saying. That's it. And okay, let's see the example. Right. So person 3 is not multidimensionally poor because person 3 is not deprived in anything. So we can safely say that person 3 is not multidimensionally poor. Okay. Now the question is, does it matter if he or she experiences an increase in any of the dimensions? And the answer here is no. And this is the deprivation focus, which says that if a joint distribution is obtained from the another one by an increment in achievements in non-deprived dimensions, then there should not be any change. And that is going to include the multidimensionally poor as well. Okay, so if you have any change in the non-deprived dimensions, even for multidimensionally poor, there is not going to be any change. That's deprivation focus. So this is the example. Now this person, suppose this person can be identified as poor or not poor depending on criterion. If he was an intersection criterion, this person is not poor. If you are using an intermediate criterion of 2 out of 3, this person is identified as poor. However, this is the dimension where the person is not deprived. So if you have an increment in this particular dimension, there should not be any change in poverty. So it's just looking at deprivations. So if you have any change in non-deprived dimension, there is no change in poverty, irrespective of it's a poor or non-poor. Okay. So these focus properties, actually, it can be seen that this poverty, poverty focus property is attributed to more the aggregate achievement approach, whereas deprivation focus is attributed to the censored achievement approach. And you understand why, right? Because the censored achievement approach involves censoring the deprivations. Okay? As a result, when you censor the deprivations, it is not possible to see changes in the censored deprivations. So this deprivation focus property is more attributed to the censored achievement approach, and the poverty focus is more attributed to the aggregate achievement approach. Look at the example of an aggregate achievement approach. What was the example of aggregate achievement approach? Consumption expenditure approach, right? So for consumption expenditure approach, what you do, you allow substitution at any level. So if somebody is consuming huge amount of protein but less amount of others, it is possible for that person to be non-poor. So even if that person has increase in their non-deprived dimension, poverty changes. So it fails to satisfy the deprivation focus. Okay? But it satisfies poverty focus. Because if you identify somebody as non-poor, no matter what happens, there is no change in poverty. Yes?
I think the problem is the terminology, what we consider poverty focus and deprivation focus. Because if a person is deprived, we can say that he's poor too.
Why?
Because he doesn't have the minimum conditions too.
If you had deprived only, that's the question. The union approach, what I have said, the union approach, it identifies somebody as poor if the person is deprived in at least one dimension. That means any dimension. Okay? But you might say, well, I do, Sabina gives the example all the time, and she will come back to that example. Suppose somebody is doing modeling, and she has to be thin. And so she is, looks like her body mass index is less than 18.5. Should she be identified as poor? From our point of view, she is deprived by whose standard? As deprived in health, but should that person be identified as multidimensionally poor? Or, I mean, there could be another motivation against union approach is that suppose there is a measurement error. Okay, somebody is by accident, the person is, his data has been put wrongly, so he's not deprived in any other dimensions but in one dimension by mistake. If you take an union approach, this person will be, there is a likelihood, and by error you are going to be counted that person as poor, but the person is actually not. Now if you have multiple dimensions, if you look at more than one dimension, then there is possibility that the chance of inserting wrong data for two dimensions probably is less likely than the chance of error in one dimension. Okay, so that could be another motivation of not using the union approach. There are several others, and we will come back to it over time. There was a question? Yes?
Can you establish the poverty?
We have just a minute. We have a question back, and then we will come back to you.
Yeah.
You have to use both. You have to use both microphones at the same time. One for us, and the other one is for the videoing.
Yeah, actually I was waiting for this question, and now I think it's the right time to ask because you already picked up. If you look at various literature on poverty, you could find words and concepts as deprivation, meaning like poverty, and I'm really not clear when we say deprivation, if it is really different from poverty, because this concept has to be really clarified and popularized, The second question is the indicators that we use for multidimensional poverty analysis, we need to have some variables where we could be able to really sort out. These are the variables that can be used as indicators of multidimensional poverty. If for example, I'm interested in looking at 6 or 7 variables as explanatory for multidimensional poverty, and you may have come up with some 10 variables or 20 variables, And anyone interested in studying multidimensional poverty could come up with various number of variables, and on such conditions it's very puzzling sometimes to know what exactly are the number of variables that we use to measure multidimensional poverty, because at the end of our analysis we need to have, you know, a standard approach.
Yeah.
Thanks.
Yeah, very good questions. Look, the focus of this lecture, especially to provide the framework, what you are asking is an empirical question. Okay? And if you look at the schedule, we will have a session on understanding association, redundancy, and all such things. Okay? So your question is a very valid question. But I think let's wait for that particular session to come, where we are going to be discussing about the number of indicators, how they should be chosen, what kind of association, you know, we should measure between them. It's definitely important that the number of variables, you know. Your first question is about distinction between deprivation and poverty. In the single dimensional approach, it has been the case where people have used the term poverty and deprivation synonymously, which is not the case when we are using sort of a censored achievement approach. What we are doing here, we are identifying if a person is deprived or not in a particular indicator. As I said, if your criterion is that you identify somebody as poor if the person is deprived in any one indicator, then deprivation is equivalent to poverty, right? Deprivation in any dimension implies poverty. However, if you are moving beyond, suppose you are taking a completely extreme approach, you are saying I am going to identify somebody as poor if the person is deprived in all dimensions. Here deprivation does not necessarily imply the person is poor. Here deprivation is different from poverty, right? If you are deprived, if you are not deprived in even one dimension, you are not identified as poor. So yes, the idea of poverty and deprivation in the multidimensional framework that we are working, it's quite different. It's not the same. Okay? Do I clarify? Yeah.
It helps us a lot, because when we are defining poverty, when we are measuring the absolute poverty,
Yeah.
the meaning has been that it is absolute poor, the one who's deprived, that is destitute or deprived.
Well, you are using different terms, we use differently, yes.
Yeah, so that's what brings the confusion, because the concept of absolute poverty is very much linked to being deprived of everything, being destitute. So the way we are bringing it now is somewhat different. And I think that's the confusion that has been going around people's heads.
Yeah, so we will distinguish the term deprived, poor, destitute. That is different as well. Okay, so hopefully over time it will be clear. But let me clarify at this moment that deprivations and poverty in here, they are not synonymous. Okay, so it is possible you have to be deprived in certain number of dimensions to some extent in order to be identified as poor. And so it is possible that non-poor may be deprived in one dimension, like our model, deprived in health. Okay? Good. Yes, please. Gisela. Here, please. Thank you. Gisela is doing a lot of running around.
When you address her previous question,
Yeah.
you give her two specific examples.
Yes.
Number one is if that person is a model, then we are not going to consider her as a poor, even if her body mass index is not correct. And number two is measurement error.
Could be.
But the thing is, we are going to have a large sample, let's say 50,000,
Right.
or basically 18,000, 50,000 EDC, etc. So in such large sample, the proportion of population having such problems will be very few, maybe 5, 6 or 16 people will have such issues And basically,
You mean this particular example that I gave, or
Yeah,
because
yeah.
there could be 1,000 such examples? In that way, if you have one from each, you will have 1,000 observations.
Yeah, so my thing is instead of cutting a certain, for example, two deprivation, why not reporting all deprivation and suggest, for example, if the deprivation is, we suggest if leaving the decision of making who is poor for the reader.
You leave it to the reader to
decide.
Decide it. Yeah, of course not. You are suggesting an approach where user can choose their own poverty line.
Yeah.
This is what exactly you are saying.
Yeah.
It is possible.
Basically, if the dimension are chosen, then they are chosen on purpose. So if one person is missing
yes.
that one,
Yeah.
For me, he should be identified as a poor.
Look, I mean, those are normative decisions, and how you choose poverty lines, of course, is a normative issue, and we will revisit this issue. Okay, I mean, there will be different criteria that will come up, and you are talking about one such criteria to choose. You are saying that if you and I are there, I choose my deprivations and decide, right? It's a choice. Your choice and my choice is going to be different in that case.
What I mean is the poverty are the deprivations are determined.
Deprivations are determined
Based on criteria, a certain criteria. For example, education, health. They are already determined, and they are supposed to be important. Yeah. If I'm deprived by education, for example,
right.
I should, even if I am good in other dimensions of the measure,
right.
Then I should be categorized as a poor.
And who chooses that? So you are saying if you are deprived in education and nothing else, and still you are identified as
a poor.
As
I
poor.
Should be identified.
That's an
as
union approach. That's what I'm saying. That's an union approach. When can you justify union approach? The idea is that if you are saying I have chosen these 4 dimensions, and each of these 4 dimensions is intrinsically important, a rightist approach, a right-based approach rather. You are saying each of these 4 rights are important. Okay, if you have such situation, you can definitely go for union approach. Okay, so there are different contexts, and that's what I'm saying. This is not the right class to discuss this. We will come back to this issue. They are normative issues. Okay, we will come back to it. Yeah.
For further discussions, can you use the whiteboard?
Whiteboard?
Yeah, because some of the questions they're based on the examples you're giving, and it could easily be discussed there.
So you want to write down the points in the whiteboard so that you can revisit afterwards?
No. What I'm saying is, when you explain some of the terms, I think it's better to use the whiteboard because.
Okay, you want to be written in this whiteboard so that it's there in your head when you were reading it. So, so for example, poverty and deprivation.
Yes.
Right?
Like the examples we gave, everybody asking the same questions.
Sorry? Okay, Sabina is saying we have a terminology slide tomorrow. So, okay, so we come back. We were not very prepared for this particular thing, but yeah. So I have half an hour, so let's finish, but definitely we'll come back tomorrow. Yeah. Somebody is helping us, or you cannot see, I blocked you. well, that objection totally prevent me to write down at this moment. Let's go ahead. We'll follow Sabina's slide tomorrow. Sorry about that. I blocked him. Okay, so let's move on. So this particular property that is new. Okay, it was not there when we're doing the unidimensional measurement. It's called ordinality. This is a property that in a paper Sabina and James has introduced, which is also available in the book, the copy that has been circulated. And the main idea is that if a vector, if a achievement matrix and the corresponding deprivation cutoff is obtained from another achievement matrix and deprivation cutoff, as equivalent representation, then poverty should not change. What is equivalent representation? Technically, it's a monotonic transformation of each dimension and its deprivation cutoff. Same monotonic transformation. Let me give you an example. Example is clearer than just the definition. Suppose we have this particular situation where we have this particular achievement matrix, 4, 3, 8, you have 9,000, 9,000, 15,000, 0, 1, 1. And suppose this is the years of education, this is suppose the incomes, and you have suppose an access variable, access to healthcare. Okay? And given that this is a ordinal variable, we just give a value of 0 if you are if you do not have any access, and we give 1 if you have access. Fine? And these are the deprivation cutoff. So for education, the deprivation cutoff is 5. For income, the deprivation cutoff is 10K, which is 10,000. And for access, definitely the deprivation cutoff is 1. If you have access, then you are not deprived. And then you have this a matrix where the numbers, it's really difficult to understand how this matrix was obtained from this matrix. This is how it has been obtained. What I have done for education 438, I have just converted it into months. So instead of years of education, I have months of education. It is quite usual to take log of incomes. So I have taken a log of incomes here, and then this is a value ordinal variable. It does not matter what value I assign as long as we have order, who cares. So we had 0, 1, and I just added 2 with each. So we have a matrix, transform matrix from here to here. I have done the same thing. Oh, did I? No, this should be 5 times 12. This should be 60. Please read it as 60. It should be 60. Then you have log of 10,000. You get this. And then you have this as x plus 2, which should be actually, it should be 3. Wait a second. I have added, no, it's just 3 and 5, it's fine. This is wrong here. Okay, I have just taken any two values, 3 and 5. Anyway, this is just any order. And you have, so it's 5 here. So you have, so this identifies, I don't see any difference in these two things, right? It's just transformations. I have just taken transformations. That's it, nothing else. Do you think poverty should change? Okay, that's it about this ordinality. So these are called admissible or equivalent representation, because these are equivalent. If you report it by years or months, it should not make any difference. If you just report by, so you see it's not just scale invariance. Scale invariance was about multiplying, okay, changing the proportions. That was scale. It goes even further. It looks about any monotonic transformation of ordinal variables, even including ordinal variables. So here you have a mix of cardinal and ordinal variables, okay, and you are taking any transformation. And this is something, for example, you will see many poverty analysis in different approaches that we will discuss tomorrow. It could be statistical approaches, fuzzy set approaches. Sometimes the ordinal variables are forcefully cardinalized. So if you have say sanitation, you have 4 different categories, and you have assigned a value of 1, 2, 3, 4, and you use this value of 1, 2, 3, 4 to do the aggregation. When you change this 1, 2, 3, 4 to 1, 7, 15 to 71, you have the order, but you will completely get a different poverty analysis. What ordinality is saying that if you change this kind of orders or monotonic transformations, poverty should not change. Yes, please. Mic. 2 mics.
Why don't we have this same property also in the unidimensional case?
You could, but the problem was we were working in the unidimensional work. I did not assume any ordinality, so I allowed, cardinally meaningful numbers, say consumption expenditure. You have a cardinal meaningfulness because you can see the difference between the 10,000 and 15,000. There's a meaningful difference. So it's cardinally meaningful. You see, so that's why I did not introduce any ordinal properties. Okay, any other questions before I move on? Now this is the question why ordinality property is important. The practical importance is real world data. Monotonic transformations are sometimes inevitable, say log transformation of incomes. Sometimes people take log transformation of education variables as well. Now here the scale of variables is quite important. So we have a section on scale of variables, is chapter 2.3, section 3 of chapter 2. And generally there are 4 different kind of scales. One is ratio scale, where division and multiplications are applied. They make sense. Okay. For example, income. Interval scale, where you have additions and subtractions, they're allowed, but multiplications are not allowed. For example, one example you could see, I guess, using Fahrenheit, conversion from Fahrenheit to centigrade. Okay, it's interval, it matters. You know the difference between, say, 5 degrees centigrade, 7 degrees centigrade, and 7 degrees centigrade and 9 degrees centigrade. They're same, the difference. But when you convert it to Fahrenheit, the same difference doesn't hold. And then there are ordinal variables, where you only know that the order matters. You do not have any meaningfulness between the numbers. In temperature, you could say that in centigrade, the difference between 7 and 5 is same as 9 and 7. There is a difference. Difference matters. For ordinal variables, you only know it is hot or cold. You do not know how hot or how cold. Okay. The access variables. You have access to sanitation or not. You have piped access through pipe. You have toilet. You have flush toilets. You have pit latrine. You are going to bush or field. We do not know the exact difference, how good one is from the other. We only know one is better than the other or which one is worse. That's it. Okay. And finally, the nominal and categorical variables, which does not even have any order. For example, gender, ethnicity. It's hard to say who is better, women, men. It's hard to say which ethnicity is better than the other. Okay, so you don't have any order. So these are the different kind of scales. So for ratio scales, when you have income, you know that if you multiply by 4, 15,000, 60,000, that means you are 4 times richer. That makes sense. Yes, we have a question.
Just I'm a bit confused about an inconsistency. Is that if you're saying that you can only apply multiplication to ratio scales, and income is a ratio scale, then in your previous example you applied the log transformation to income, and you're saying people frequently take the log of income.
Mm-hmm.
So in that case, we don't count it as an admissible transformation.
Good question. Let me think about it. I do not have a direct answer at this moment. Let me think about it. I'll get back to you. Okay. Finally, we come to the dominance properties. Okay. So dominance properties, first one is monotonicity. Can anybody remind me what was monotonicity? Person's achievements. So the main idea was, if you had, because focus was talking about do not change poverty if you have change in the achievement of the non-poor or non-deprived, right? Now when you look at monotonicity, it is saying that if you have a reduction in a poor person's achievement, what can happen? Poverty should increase or decrease? If you have a reduction in a poor person's achievement, poverty, so monotonicity, the strict person says it should increase, the weak version says it should not decrease. Okay? So that is the monotonicity property. And this is the example. So if you have, say, this person, so this person is definitely poor, no? In how many dimensions this person is deprived? All dimensions. So even if you use the strictest criteria, this person is identified as multidimensionally poor. And this person, if you go here, has suppose an increment in the achievement, the opposite to decrement. What should happen here? Poverty should fall. So if you move from here to here, poverty should fall. If you move from here to here, poverty should increase. Okay. Now, yeah. Yes, go ahead.
Yeah, I think on this property, I was just thinking as well, even in on focus property. You know, sometimes there are certain dimensions whereby an increment does not necessarily mean an improvement. Yeah. That's something like I was thinking of the family size. An increment in the family size makes maybe the household deprived. So I was thinking when an increment is made, then the household falls and becomes deprived. Doesn't that going to increase the poverty?
You always have the option of transforming a variable in such a way that higher value implies improvement. So what you can do, if you have the number of the family size, you can take its reciprocal. So 1 over family size. If you do that, then higher value will mean better. So you can always make such transformations here in order to identify. You see the point? It's possible. And these are practical things. Okay, of course it's already say people per bedroom. If you have people per bedroom going up, it's actually bad, isn't it? So in those cases, in general, people transform in such a way, say you take 1 divided by that number, okay, then higher value implies better situation. These are the practical solutions that are taken in these kind of situations. So the achievement matrix, higher value always means something better for the well-being. These kind of things are these are the practical solutions. Okay. Now this is particularly attributed to multidimensional context. What is the idea? If you find a particular poverty measure, multidimensional measure is strictly satisfies strict monotonicity in strict sense, we may not require this particular property. But every property has a weaker version. Weaker version means that if this particular transformation takes place, it does not increase strictly, that's fine, but it also does not go in the opposite direction. So there's a weak sign. So it is possible for some measures that is not that does not satisfy strict monotonicity. It probably satisfies weak monotonicity. As a result, when you have, say, increment in the achievement of the poor person, poverty may not change. In those kind of situations, this property becomes important. And as we'll see, this property will be clear, much more clear when Sabina introduces the adjusted headcount ratio based on which MPI was computed. MPI versus the multidimensional headcount ratio. What happens in multidimensional headcount ratio? You just count the number of poor. Now in that case, if a person becomes deprived in an additional dimension, headcount ratio does not change. Because a person was poor, it has become deprived in an additional dimension. No change in poverty, right? Dimensional monotony says that a particular poverty measure should be sensitive to that kind of transformation. So if you have a poor person being deprived in an additional dimension, then the overall poverty should reflect that by increasing the number. That's where dimensional monotonicity comes into play. Now if we have a particular poverty measure which satisfies strict monotonicity, that automatically satisfies dimensional monotonicity. But in some cases, when you use the 0-1 variables, it is really not possible to look at the changes in the dimensions. There, the dimensional monotonicity becomes crucial. So So you will understand the property better when the adjusted headcount ratio is introduced. Let's move on. I have 15 minutes. Transfer in the unidimensional context is, I will introduce it, and this is something that we will not be focusing too much in this particular summer school. But still, I'm introducing this concept because some of the relevant properties will be used. So the main idea, recall the unidimensional context. The main idea was, what reduces inequality? If you have some income taken from a richer person given to a poorer person, or from a richer poor to a poorer poor, you have reduction in inequality. That's the basic idea behind the transfer principle. Okay? And it is called progressive transfer. In other words, if you see two situations where you have similar average, but in one distribution, incomes or achievements are much more dispersed. It could be education, it could be income, they are much more dispersed. Okay? Then it is much more unequal. And even if you have such disparity among the poor, that should be harmful for poverty. That's the basic idea behind transfer principle. In the multidimensional context, when we apply such concepts, it requires more cardinal data. Because if you have just axis 0, 1, how can you sort of transfer? It's either 0 or 1. So there is something called dimensional transfer that also Sabina and James introduced, and we'll come back to that. But before going that, let's just show you, suppose you have 3 cardinal variables where transfer is possible. Okay? And so how does it take place? So the main idea is that, let's focus on the single dimension at this moment. So we have this particular 2 vectors in single dimension. Now there is something called a bistochastic matrix. The idea is whose row elements and column elements sum to 1. So look at this matrix. You have 0.5, 0.3 and 0.2, they sum up to 1. 4, 3, 3 sum up to 1. 0.1, 4, 5 sum up to 1. Similarly 0.5, 4, 1, they sum up to 1. They sum up to 1. Okay, so what it does, it smooths the distribution. Let's see how it does. Oh dear. Okay. So suppose you have this bistochastic matrix here, and this is the vector 4, 8, 16. So if you multiply these 4, 8, 16, this particular income vector by this bistochastic matrix, you get this particular vector. Look, inequality has gone down in this particular vector. Similarly, if you want from here 4, 8, 16, if you want to get a completely equal distribution, the bistochastic matrix would be 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3. So if you have all matrices as 1/3, you will get a completely equal distribution, which will be 8 plus 16, 24, 20 divided by 3. Completely equalized. Okay. So now suppose we ask what bistochastic matrix is used to obtain this from this, because here you have 9 and 15, okay, but here you have 5 and 7, you have 4 and 8. So this is more unequal than this one, right? This is 5 and 7, this is 4 and 8. Now if you ask which bistochastic matrix is used, I am not going to ask you to solve. This is the idea. This bistochastic matrix is going to be used to get this particular vector. You may solve when you are at home in the evening. Let's not do it now. Okay. Now this is something that I did not introduce, something called uniform majorization, but the idea is that if one distribution is obtained from the other by multiplying this bistochastic matrix, so if you obtain the process of obtaining one distribution which is less unequal from another distribution using such bistochastic matrix, this is called uniform majorization. That's the intuition behind it. So if you have, if you multiply this by this, you get this. You see, it's for each dimension it has been smooth. Okay. So you have these 8, 3.5, 3.5, sorry, it was 4, 3, 8, you multiply by this, you get this. So each dimension has been smooth. So transfer says if y is obtained from x by uniform majorization among the poor, okay, and averaging of achievements among the poor, then it goes down. So you have same level of average income among the poor, but one is more unequal. If it is more unequal, even with same average achievements, poverty should be higher, the distribution which is more unequal. And then there is a corresponding weaker version. Now the interesting thing is that if a poverty measure satisfies focus, deprivation and poverty focus, it is not possible to satisfy transfer in strict sense. So just to know, so if somebody asks you to develop a measure that satisfies strong transfer and satisfies poverty focus in multidimensional context, okay, deprivation focus especially, it is not possible to satisfy this property. That is an impossibility result. Okay, one can only satisfy this weak transfer. Okay, let's move to this property which will be useful for us in the rest of the summer scope. Okay, after these two properties, I should stop. There could be some technical properties, but they are extension from the single dimensional case. So rearrangement. Consider these two different matrices, achievement matrices. In this one, person 1 has achievement 7, 7, 2, person 2 has achievement 3, 3, 8, person 3, 10, 10, 12. In this one, 7, 7, 8, 3, 3, 2, 10, 10, 12. Let's look at the dimensions separately. You look at this dimension, look at this dimension. Any change? No. Look at this dimension and this dimension. Any change? No. Look at these dimensions and these dimensions separately. Any change?
Yes.
If you look at separately by symmetry, if you use the symmetry property and just compare this one and this one, that's the same. So if you look at different marginal distributions separately, there has been no change in the marginal distributions. Agree with that? They're same, because this is same with this one is same with this one, and this one is same with this one. However, if we look at jointly, are they identical? What is the main difference?
The order of
Yes, and the intuition? So first one, the second one becomes here deprived. Right. Right. So actually here you have 1 poor multidimensional. Here you have to actually, it could be 2. Okay, and here you have only 1 for sure and others are not. So are these two societies the same? Where do you have higher poverty? Sorry. Which one? This one has higher poverty? Depends on your judgment. If you look at sort of the inequality, here one person is poor but severely poor. At least deprivation is shared here. This person is not poor in all dimensions. This person is not poor in all dimensions, but here clearly one person is severely poor. It is as if a group of people in one country is severely deprived, others are not.
and also inequality, also social inequality.
If you look at inequality, this society looks more unequal
Yes.
than this society. Louder, please.
For the second person is like the intensity of poverty.
Exactly, it's more intensely poor, it's deprived in everything. It just has nothing. So one side you have people who have everything, who have no deprivation at all. The other society, and here one person has all the deprivations. So the marginal distributions look the same, but if you look them jointly, that's the importance of looking at deprivations jointly. So if they are your MDGs, and you look at these MDGs separately, you will say there has been no change. These two societies are the same. But if you look them jointly, then you will be able to understand that the more kind of distribution within a society. Okay? So of course the pattern of probability is not different. What is the main difference? So both matrices have the same marginal distribution for each dimensions but different joint distribution. Right? Agree? So it requires a property sensitive to joint distribution and which was motivated more than 30 years ago by Atkinson and Bourguignon, and then also by Boland and Prosten, but it's in Journal of Multivariate Analysis, and this is one of probably Review of Economic Statistics, Review of Economic Studies. So this property is intrinsic to the multidimensional case. You do not need this kind of property in single dimensional case. You have only one dimension. Joint distribution doesn't matter, but it's very specific to the multidimensional case. Again. So there are different ways to call this data transformation in the literature. If you move from X to Y, it's, you know what, it's about correlation between dimension. When you have all the, if you look at here, all the dimensions are now perfectly ordered, you see? Here it was not. So when you move from this to this, it has been obtained by increasing correlation between dimensions or increasing association between dimensions, because in this one they are ordered 7, 3, 10 and 8, 2, 12. They are perfectly ordered than in this one. So if you compute the correlation or association between this dimension or say this and this dimension, they are much lower compared to what you have it here. So this kind of transformation is actually related to the correlation or association between dimensions. So if you move from X to Y, in the literature it is variously known as association increasing rearrangement, correlation increasing transfer, correlation increasing switch, and so on. And if you move from Y to X, it's called association decreasing rearrangement. And this is the concept that Sabina and James use in their paper. So the question then is, again I'm just moving fast, then the question is, how do you think poverty should change under an association decreasing rearrangement? So if you move from your right to left, how should poverty change? That's the question. In theory, and it's really difficult to, always, theory does not always work very well in practice. In theory, if all dimensions are substitutes, okay, then poverty actually should decrease. If you move from here, because if you move from here to here, it raises inequality, okay, then poverty goes up. But if you move from here to here, which is association decreasing rearrangement, poverty should decrease here, okay. This is the idea. If dimensions are complements, and these are results from Bourguignon and Chakraborty, if dimensions are assumed to be complements, then poverty should increase when you move from here to here. The main idea is that when dimensions are complement, that means you cannot wear a right shoe without a left shoe. So in order to enjoy one dimension, you need more of other dimension. If that is the case, then it is probably more efficient that somebody has all these dimensions together. And if that is the assumption, that's a very theoretical assumption. If this is the assumption, then people are here, they are better off. But in general, this is not the case. It's really hard to assume that all dimensions are complements. If dimensions are neither substitutes or complements, that means the so-called independent, that means no one can affect anything, then you can say poverty does not change. However, the joint distribution it's independent, so it does not matter whatever has happened, poverty should not change. But these are theoretical assumptions based on Bourguignon and Chakraborty. Now, what happens is that if you look, and I will give you an example, that switches can take place between, it's just switch, and switches can take place between the non-poor. If the switches takes between non-poor, should that affect poverty? If the switches are between non-poor, it should not, right? Because of the focus axiom. It should not. So, what we do, we define association decreasing deprivation rearrangement among the poor. That means the deprivations has to be rearranged in order to affect poverty, because if that takes place among the non-poor, it is not going to affect poverty. So what is an example of not an association decreasing deprivation rearrangement? So if you have this kind of situation where the switches are taking place between, say, these two persons, are they poor, this first and third person?
No, they are not.
So the first person and the third person, they are not poor. So if you have switch between them, then it is not an association decreasing deprivation rearrangement among the poor. On the other hand, this is an example where you have this person deprived in that dimension, and you have, and suppose they are poor, they are identified as poor. So if you have switches like here, then that is called an association decreasing deprivation rearrangement among the poor. And if you have such deprivations, you have such switches, that should affect poverty, not them. However, anyway, I mean, theoretically we have to define the properties assuming substitutability and complementarity. Okay? And we call deprivation rearrangement, it's substitutes. If y is obtained from x by an association decreasing deprivation rearrangement, then you have poverty going down. Converse deprivation rearrangement, which is the case for complements, if y is obtained from x by an association decreasing rearrangement, is the other way around. Okay? So these two properties are quite based on this assumption of substitutability and complementarity. The problem is that it's the first thing that even in theory of forms in economics, it's really difficult to find a function which allows different rate of substitution between different groups, different commodities. And this is the concept has been brought here. So first of all, it is really difficult to find a functional form which allows different level of substitution. The only thing that we do, we allow same rate of substitution mostly between different dimensions. That's the first issue. The second issue, it is not possible, or it is really difficult to consider two dimensions as substitutes and others as complements. That is also not allowed. So you can either assume all substitutes or all complements with the same rate of substitution. That's a very difficult assumption. Okay, but the main idea here is that at some point higher correlation is bad, and under another assumption higher correlation is good. But in general, the higher correlation is bad is more trustworthy rather than higher correlation good one, intuitively. Anyway, this is the final dominance property, which is dimensional transfer. This is actually more user friendly and more practical. What it says is that if y is obtained from x by a dimensional rearrangement among the poor, then poverty should be lower. What is dimensional rearrangement? Dimensional rearrangement comes from the transfer principle in the single dimension. Okay? So suppose you have two poor persons, and you have 4 dimensions. In one society, one poor person is deprived in 2 dimensions. In another society, a poor person is deprived in 4 dimensions. So 2 and 4. In another society, both are deprived in 3 dimensions. So the idea is that although you have same average level of deprivation, where you have larger inequality, poverty should be higher. You should discount for that. That's the main idea behind dimensional rearrangement. So this is an example where deprivation rearrangement among the poor, but not dimensional rearrangement, because the main idea here is that the deprivation and non-deprivation has not been switched. Okay? Here you are both deprived, both receives a value of 1 and 1. So deprivation and non-deprivation has not been switched. So this is a deprivation rearrangement definitely, but not a dimensional rearrangement. So this property will be much more clear again when the adjusted headcount ratio is introduced. So you will be able to see this property much more clearly than just here in an abstract way. And these are the subgroup properties I have already been through, And there are two properties again. One is subgroup consistency. Can you remember what is consistency of subgroups? Anyone?
Poverty increases in one subgroup overall.
In the same direction. So if you have a change, if you have a reduction in poverty or increase in poverty in one subgroup, but remains constant or no change in others, this is the consistency requirement, that the overall poverty should change in the same direction. And population subgroup decomposability?
Multiplying by the shares of the population.
Right. So if you have the subgroup poverty levels and if you know the population shares, then the overall poverty can be computed as the population share of the subgroup poverty levels. That's the idea. Now there is another type of decomposition, which is dimensional decomposition, which was not possible in single dimensional analysis, right? In single dimensional we had only one set of vectors. Here suppose you have three different dimensions: income, education and health. So you have income, you have education and health, and you may want to know what is the contribution of education to overall poverty. Isn't it a valid question? Suppose you have a change in poverty over time. Your poverty has gone down. You may want to know which has caused this change. Has it been caused by a reduction in education? Has it been caused by reduction in income or reduction in health? In order to, for evaluation purposes. And this particular property helps you in this, answering this kind of question. So it is of course purely multidimensional concept where the overall poverty can be expressed as a weighted average of dimensional deprivations among the poor. And if we denote the dimensional deprivations by these, suppose you have, after you identify the poor, you identify the post-identification dimensional deprivations of the income, of education and health, then the overall poverty is just a weighted average of these dimensional deprivations. That's the main idea of dimensional breakdown. So just like population breakdown, you break down the population subgroups and you compute the subgroup poverty. Similarly, you can break down the overall poverty across dimensions to understand the contribution of dimensions to the overall poverty. Okay, and of course these are the technical properties which you have already seen. Normalization, that means poverty is bounded between 0 and 1. Continuity, can somebody tell me what continuity does? Prevents the jumps, sudden jumps in poverty levels. And this is an assumption which, this is a property that is used when you have all the weak dominance properties, as happens with adjusted outcome ratio. It just says that a poverty measure should take at least two distinct values. Otherwise what happens? You have change in your deprivations, poverty does not change. It is possible to happen in theory, so this is just a technical property. Okay? I stop here. It was a marathon one. And as Sabina said, it was the most difficult one, the last two. The rest of the summer school is not going to be like that. Okay? But they were required for you because in order to understand why you are using a particular poverty measure, it's really desirable to understand the kind of properties that they satisfy. Otherwise, you use a poverty measure and you face different kind of questions. Why you use this? Why you use that? How did it change? How did this change, particular change take place? And in general, unless you understand the properties, it's really difficult to answer because you do not know what kind of changes are going to happen. Tomorrow morning, we will discuss some of the multidimensional measures that are frequently used, statistical methods, fuzzy sets, and you will see in many of the cases, there is no consideration of understanding of these properties. So some of the results, when we obtained, we say that poverty has gone down. Actually, poverty should increase. Okay, so you have to be very careful when you are doing different kind of analysis and at least understand what are the different kind of transformations that are responsible for increase or decrease in poverty. Okay, let's stop here, and if you have any question or answer, please feel free to. Else, I break it here. Thank you. See you till tomorrow.